Let's talk about strings in Java. To begin, create a new NetBeans project and enter the main function. Then let's declare two variables, a character called C and a string called S. Right away, it becomes clear to us that string is something a little different. You'll notice that NetBeans did not choose to color code blue our string keyword, as it would have done if we were declaring a variable of a primitive type. This is, of course, because string, unlike character, is not a primitive type. String is what we call a class. Classes are the backbone of object-oriented programming. Just as we can declare variables of a primitive type, we can declare variables of a class called instances. Right here, our variable S is an instance of the string class. Unlike variables of primitive types, instances of a class can contain their own special methodologies and functions declared by the class of which they are an instance. In this video, we'll be using some of these string-specific methods and functions to manipulate text. But first, let's take a look at what makes strings so special. As we know, we can pretty much use interchangeably our character variables and our character literals. Same with just about any other primitive type. Strings also map interchangeably with the string literal, which is like a character literal but uses double quotation marks and can contain many or no characters at all. Most Java classes do not map to any sort of literal, and the ability for us to manipulate string literals through the string class is what makes it so valuable. Another thing strings can do that most Java classes cannot is make use of the addition sign operator. If we declare three strings, we can set the value of our third string to be one string plus another string. We can even add a string literal into the mix. If we then print string number 3, we'll see these three strings added together in much the manner that we would expect. So I promised you that strings had functionality not seen in a simple primitive type. To employ this, let's navigate to the string class in our Java documentation, which lives in java.lang.string. As with the documentation for all Java classes, the string documentation contains a method summary, which will tell us all of the functions we can call on an existing string object. If we scroll down in the method summary, we'll come to the toUpperCase function, which converts all of the characters in this string to uppercase. Let's employ this function now. Back in NetBeans, we now need to determine where the best place in our program to employ our toUpperCase function is. We know we need to employ the function after line 8, because before line 8, the value of S3 is not yet finalized. We could employ the function on the line immediately following 8, or we could use it as part of the line where we print out the value of S3. Instead of printing out the value of S3, we could, if we wanted, simply print out the value of S3.toUpperCase. If you'll remember from our documentation, the toUpperCase function requires no arguments. It knows that it's being called by S3, and that's all the knowledge it needs. But we still provide the double empty parentheses so that Java knows we are in fact making a function call. If we run this program now, we'll get the uppercase version of the string as we expected. But it's important we understand what's going on behind the scenes here. line number 12 is not modifying the value of S3 and then printing out that value. Rather, our print line statement evaluates S3.to uppercase and then prints out the string returned by that function. To see that the actual value of S3 is not modified by this function call, we can print line the value of S3 again and see that it keeps its lowercase components. If we had wanted to permanently modify the value of S3, we would want to do that on a previous line, and we would set the value of S3 to the function's result. To confirm that we're all on the same page, let's employ one more methodology from the string class. If we head back to our documentation and scroll up, we can find the string's replace method. Unlike our toUpperCase method, which took no arguments, replace takes 2 characters as arguments. The function will return a new string where all instances of the first character we give as an argument have been replaced with the second character we gave as an argument. Let's utilize this function on our first print line. We'll go s3.replace and give our function 2 characters as arguments. Let's replace the character G with the character O. If we run our program, of course, nothing happens, because by the time we've gotten to line 12, there are no lowercase g's left in string 3. There are only uppercase g's. Now, if we run our program, we see the replacement happen on the first instance of print line, but not on the second instance because we haven't actually changed the value of S3. Excellent. You should now be well equipped, as long as you have the Java documentation handy, to call all sorts of string methods. If you spend a lot of time working with strings, though, I anticipate that you're going to run into a common problem. Let's take a look at it quickly. I'm just going to comment out all the code we've written so that it doesn't run at all, and essentially write a brand new program here. I'm going to declare a string, and then I'm going to have our program print the string to the screen. But the value I'm going to assign to this string is going to be a little tricky. I'd like our program to print out the text, "The program says, hello world." And I'd like hello world to be surrounded by double quotation marks. The problem here is that putting double quotation marks inside a string literal confuses Java. When it reads through our program, the first full string it sees is "the program says, :space." And then this double quotation marks tells Java that we've ended our string. This is, of course, not what we want. Fortunately, there's a system in place for us to tell Java that we'd like a character to be treated as a character literal instead of the special functionality that it might otherwise have. To do this, we put a backslash in front of the character. Now, when Java reads through this string, it will read "the program says, :space," see the backslash, and know to treat our double quotation mark as double quotation mark the character instead of double quotation mark that surrounds a string. When we run our program, we will not see these backslashes. They themselves are special characters. If we do want to see a backslash in our string, we need to preface it by a backslash of its own. And that's Strings 101. Thanks.